This is the solution for the free response question number 7 from the package that was given to you over spring break. So these were the 3 things that you were told, that there's a region bounded by these graphs on the y-axis. This is with a calculator, so you should not waste any time doing anything by hand. And if you graph this on the calculator, you'll get a picture that looks like this. This one is y equals radical x. That one is y equals e to the negative x. And so it's bounded by those 2 graphs and the y-axis. So the y-axis is here. So therefore it's got to be this red shaded piece here. And so you can see that the top is going to be the e to the negative x. So I'm going to write that top. And the bottom is going to be the radical x. So the first question is to find the area. So the area is just going to be the integral of the top minus the bottom dx. Okay, so we already know that the top is e to the negative x minus the bottom. The bottom is radical x. And now you just need to figure out what the interval is. Okay, so the first part's easy, that it's at 0 it meets. Then you have to figure out where are these things intersecting, and that would be right here at that yellow point. So you're going to use your calculator for that. You're going to put the 2 functions in. So you're going to put this one into y1, you're going to put this one into y2, and then you're going to graph it, and then you're going to go into second calc and choose intersect, and you will find that they intersect at 0.4263. So this is a calculator question again, so you're going to put this into your calculator by using the math9 function. And then the first thing you're going to do is you're going to put in the actual function. That's this right here. But that yellow doesn't look too good. Hold on, let me fix that. Okay, so you're going to do math9. You're going to put this in there first. Then you're going to do comma x, comma 0, comma 0.4263. And after you do all that, you should get 0.1615, and that was the answer for part A. So remember, this is a 9-point question, so that would have been 3 points right there, and that's not so bad. Okay, for part B now, we're going to have to work on volume. Okay, so remember that the formula for volume is going to be the integral of the top squared minus the bottom squared dx. The only thing is that this is going to revolve around the line y equals -1. So going back to the picture for a moment. Okay, y equals -1 is going to be located down here. So this thing, this little triangle piece, is revolving around that. So that means it's top minus bottom. You also have to remember that you're going to have to add 1 to each piece because it's revolving around y equals -1, so to get back to 0 you have to add 1. Okay, so our integral stays the same. It's going from 0 to 0.4263. The top function we already know is e to the negative x. So it's e to the negative x, but then you have to add the extra 1 squared minus the bottom function plus 1 squared dx. And because this is for volume, sorry, I forgot that you need a little pi over there. So you're going to keep pi separate because otherwise the calculator will give you a crazy number. And then you're going to go to the calculator and do math9, and you're going to do math9, put this whole thing in, make sure you do your parentheses right, comma x, comma 0, comma 0.4263. And when you put that in your calculator, you will get 0.519. But it's still being multiplied by pi. You're not going to do that in your calculator, and your final answer will be 0.519 pi. And that's equal to 3 points. Okay, and finally, for part C, we're looking for cross-sections perpendicular to the x-axis. So that means that you're going to want the integral of the area of the cross-section, and because it's perpendicular to the x-axis, it's going to be dx. So that means that your interval is still going to stay from 0 to 0.4263. So the only thing you need now is the area of the cross-section. Okay, so the cross-section is a semicircle, so you're going to need the area of a semicircle, which is pi r squared over 2. So the question is, what is r? Well, it's saying that the diameter runs from y equals radical x to y equals e to the negative x. So I'll just redraw the picture here. So here's the picture. Here's one function. Here's the other function. And remember, this is the piece that we're looking for. So it's telling you that the diameter goes from y equals radical x, so that's here, to e to the negative x, and that's here. So the diameter would just equal the top, which is the e to the negative x, minus the bottom, which is radical x. However, if you look at our formula, we need a radius. So it's going to be the diameter divided by 2. Okay? So I'm just going to erase this part. Okay, so we're going to have pi r, which is that big mess, pi r squared over 2. So this piece is the area of the cross-section. So now all you have to do is replace all this with this. So it's going to be integral, and we're going to have pi e to the negative x minus radical x. This whole thing is over 2 squared, all over 2 dx. So I'm just going to erase this now that we have this, just to make more room. So just rewind if you're confused by how I got all that. Okay, so this is going to be confusing for you to put in your calculator, so remember you can always pull the constant out to the front of the integral. So I would recommend pull out the pi over 2 and then rewrite the rest. Okay, and then you're going to go to your calculator and you can do math 9, and you're going to put this in there, and then you can do comma x, comma 0, comma 0.4263. Okay, and when you put in the calculator, you're going to get 0.0221. I'm rounding to 4 decimal places. So this is going to be 0.0221 pi over 2 as your final answer. So that one was a little more difficult than the first two, but if you can get 6 out of 9 points on every problem, you will be in very good shape. But this one was not undoable, it was just a little more confusing than the others. So that completes that free response question number 7.